Okay, let's look at our example 3 that deals with a swimming time versus heart rate. So Michael swam 2,000 yards right here on each of 18 days. And the scatter plot above shows his swim time for and corresponding heart rate after each swim. The line of best fit, or remember we are looking at best fit lines of the data is shown, it's also shown. So that means this straight line here. Now as you can see, this data here generally represent a movement like a negative trend like this, as you can tell. When you increase the time of exercise, your heart rate also technically, in a sense, the beat goes down. That is what this graph is saying. And so they have managed to put a line to represent a model that you can use to estimate. Now, always remember, best fit lines are used to predict the behavior of other points that you may not get there. For instance, you can use the best fit line to estimate what will happen at this point here, even though the exercise timing didn't get to 30, 37, 30 points. So you can use that to estimate that. So according to this, they wanted to use this to estimate the actual heart rate at point 32. So let's actually read the question. For the swim time that took 34 minutes, Marcus' actual heart rate, the actual means what was measured was about how many beats per minute less than the rate predicted by the line. So let's go back to 34. When we go to 34, we can go all the way and say this point right here, this point right here, the one that I've circled, and that represent, this is, remember, this is 140, it appeared is 142, 144, 146, 148, 150. So this here is 148. This point right here represents 148. And if you go straight down, the model is predicting 150. As you can see, the model is actually predicting 150. So if you look at this problem here, the model is equal to 150. Actual is equal to 148. So the model is predicting. So the question is, for the swim that took 34 minutes, Marcus' actual heart rate was about how many beats per minute less than the rate predicted. So if you look, this is the rate predicted, actual is this, and therefore the difference is 2. So it is 2 beats per second less than the actual prediction, and therefore the answer here will be B. So that is how you use this model to make these kind of decisions.